Hello, this is the section 3.1a lesson. In chapters 1 and 2, we've been talking about numbers, different types of numbers, positive numbers, negative numbers, decimals, fractions. Now in chapter 3, we're going to start talking about arithmetic. And we're going to start off with the simplest type of arithmetic, and mainly addition and subtraction. Section 3.1, we're going to break up into two parts. Part A, we're going to talk about some basic terminology and notation and symbols and pictures that we use to talk about addition and subtraction. In section B, or part B of this section, we're going to talk more about those types of pictures in depth. So first of all, let's start off with some terminology and notation. So an addition equation looks like this: a plus b equals c. Those numbers a and b are called either the terms, the add-ins, or the sum-ins. And I'll just call them terms most of the time. And then the number c on the right is called the sum. An addition equation looks like this: a minus b equals c. The numbers a and b are generically called the terms. The number a is also called the minuend, and the number b is called the subtrahend. Now, I don't know anybody who uses these terms other than textbook authors, so I wouldn't worry too much about remembering those terms. But one important term is the number c, and that's called the difference. So when you subtract two numbers, the result that you get is called the difference. Now, every subtraction problem is equivalent to an addition problem, and vice versa. And so here, this simple relationship relates addition and subtraction. So an equation a minus b equals c means the same as the equation b plus c equals a. Now, what it looks like we're doing is, with this equation, if we add b to both sides, then we get this equation over here. Terms are rearranged a little bit, but adding b to both sides is a way to remember this relationship between subtraction and addition. Now, let's do a real simple example to illustrate this relationship between addition and subtraction. And this relationship, or this example, deals with calculating the amount of change you get when you pay for a charge. So let's suppose that you pay a charge of $3.15 with a $5 bill. So of course you're going to get some change back. So the question is, well, how can you determine how much change you get? Well, probably the most common way of thinking about calculating change is with this equation right here. We take our $5 bill and subtract the amount of our charge, and that difference is the change. Now, another way to calculate change, and this is kind of an old-fashioned way of calculating change, but one way to calculate change is to start with the charge of $3.15, and then you count back money until you get up to $5. And the amount of money that you count back, well, that's the change. And so we took this subtraction equation and related it to this addition equation. These two equations are equivalent. So let's just kind of match things up with these equations up here to see how they relate. So like the a and the 5, they relate. The b and the 315, they relate. And then the c and the charge, they're related. Well, if we match things up over here on the right, we see the b matches with the 315 just like it did on the left. And then the c matches up with the change, and the a matches up with the 5. So we see how this relationship is just a specific example of this relationship up here. Okay. So let's look at some really simple word problems here dealing with addition and subtraction problems. Talk about some terminology we'll use to set these up, and then the types of pictures that we use to illustrate these. So Martin has 3 blue stickers and 2 red stickers and no other stickers. How many stickers does Martin have in all? Okay. So let's solve this simple word problem. So it says that we have 3 blue stickers, and then we're going to add the 2 red stickers, and we want to know, well, what's the total amount? So here's an equation that relates, that models this situation. The 3 blue stickers plus the 2 red stickers equals the total. And so now, of course, we can do this arithmetic. 3 plus 2 is 5, so 5 equals question mark. So there's our answer. We have 5 blue stickers. Well, let's draw a simple picture of this scenario. And the picture that we're going to draw here is what's called a strip diagram. Strip diagram. And we're going to use strip diagrams a lot throughout the rest of the semester. And when you start teaching elementary school, you're going to see strip diagrams at all levels, whether you're doing early childhood up through middle school, even high school. You're going to see strip diagrams. So I want you to become familiar with the basic idea behind strip diagrams. So a strip diagram is, let's just draw a simple rectangle here to represent these 3 blue stickers. And then let's draw another maybe shorter rectangle to represent the 2 red stickers. And then the question is, well, what's the total amount of stickers that we have? Okay. So 3 plus 2, the 3 that we started with, and then the 2 red ones, and then the total amount. That's what we want to know. So there's a simple strip diagram that illustrates this scenario. Okay. So let's look at another word problem. Kayla has some stickers. Sophie has 5 more stickers than Kayla. If Sophie has 15 stickers, how many stickers does Kayla have? Okay. So Kayla has some stickers. We don't know how many stickers she has, so let's represent that with a question mark. And then let's add 5 stickers to it. And that's going to give us the number of stickers that Sophie has, which is equal to 15. So there's an equation that represents this scenario. Now to actually solve this equation, let's convert this addition equation into an equivalent subtraction equation. And the equivalent subtraction equation would be question mark equals 15 minus 5. We can think of it as though we took the 5 over here to the right. That's the way to remember what we're doing, but really what we're doing is using this relationship between addition and subtraction that we talked about earlier. And so now we can do this subtraction on the right, and 15 minus 5 is 10, and so there's the number of stickers that Kayla has. So let's draw a simple strip diagram of this. So Kayla has some stickers. We don't know how many stickers, so let's draw a large rectangle here, put a question mark through it. And then Sophie has 5 more stickers. And so if we add 5 on to the amount that Kayla has, that's going to give us the number that Sophie has. And we know that this number is 15. So there's a simple strip diagram that illustrates this scenario. Here's another word problem. Logan had some Army guys, then Logan lost 3 Army guys, and now only has 2 Army guys left. How many Army guys did Logan have to begin with? So we're told that Logan starts with some Army guys. We don't know how many, so let's represent that with a question mark. Then he lost 3 Army guys. Well, loss, that means we subtract 3 Army guys. And now we only have 2 Army guys left. Oops, sorry, it's not a question mark. That should be a 2. It'll erase here. Well, sorry. Having difficulties here. Okay, so question mark minus 3 equals 2. And so now to actually solve this equation, let's convert it over to an equivalent addition equation. So question mark equals 2 plus 3, or 3 plus 2, whichever. And so we do this arithmetic on the right here, and we get our answer, 5. So Logan originally had 5 Army guys. So let's draw a picture of this scenario. And so Logan had some Army guys. Let's draw a strip here to represent this unknown number of Army guys that Logan had. And then it says that he lost 3 Army guys. So maybe let's draw another box underneath here to represent those 3 that he lost. And now he only has 2 Army guys left. And so there's the 2 that are left. And so from this picture, we can see that if we take the unknown and we subtract 3, we have 2. This also illustrates this addition equation over here, that this total amount question mark should equal the 2 that are left plus the 3 that we lost. So there's a very simple strip diagram that illustrates this scenario. And notice how this strip diagram isn't real fancy. It just illustrates the important quantities. The important quantities and the important ideas in this problem are the numbers 3, 2, this unknown quantity, and the relationship between them. Those are the most important parts of any word problems, the numbers involved and the relationship between them. And our simple picture here should illustrate all those numbers and that relationship. Now, when we solve word problems, the first step is to take the words in the problem and translate them into mathematical notation, and specifically equations. And when we do that, we often look for key words. So for instance, the words more or and often suggest addition. The word less often suggests subtraction, and then the word of often suggests multiplication. But the point we want to make here is that these key words are not often reliable for determining how to set up or solve a word problem. What we're going to see is that if all we do is look for key words, we're often going to come up with the wrong equation and hence get the wrong idea or get the wrong answer. So let's illustrate what I mean by that. Here's a simple word problem. Quan had some bugs. After Quan got 3 more bugs, he has 12 bugs altogether. How many bugs did Quan get? Now, if we're a student and all we look for is numbers and key words, we'll see the numbers 3, the word more, and the number 12, and we'll say, more means addition, so this problem should be solved with 3 plus 12, and we get the answer 15. And so there's this student's answer. Well, that answer doesn't make any sense. We only have 12 bugs altogether, so we can't get 12 bugs. So that answer just doesn't make any sense. And so if all we do is look at numbers and key words, we're not always going to set it up properly. So let's talk about how we can set this up properly. We said that Quan had some bugs. We don't know how many bugs, so let's represent that with a question mark. And then he got 3 more bugs. So the word more here does mean addition, but we need to be careful about what it is we're adding. We're starting with this unknown quantity and adding 3. And then it says we have 12 bugs altogether. So here's a proper equation that solves this problem. And so now to actually solve this equation, we can convert this into a subtraction problem. This would be 12 minus 3 equals question mark. And so 12 minus 3 is 9. 9 equals question mark. So there's the answer. Quan got 9 bugs. So again, the point here is that when we solve word problems, we have to do more than just look for key words. We really got to read the word problem over, think about everything carefully, and then write down our equation. Don't just look for keywords. Alright, so that's it for the section 3.1a lesson. So assignment before next class is to read section 3.1 from the textbook, and then also read the handout titled section 3.1 Types of Addition and Subtraction Story Problems. This is a very short handout, but it's going to talk about different types of story problems that we might see. Not all addition problems involve taking one quantity and simply adding a second quantity. Sometimes they're set up a little bit differently. So this handout summarizes the different types of story problems.